Hi students, this section is 4.5, working with the slope of a line. So there is a formula when we're working with slope of the line, and I will go through that here in a minute with you. But the definition for slope of a line, that is the slope of a line is the ratio of the vertical line to your horizontal line. And we're going to be looking at examples of solving with slope and then graphing a linear line based on the slope that we find. So for instance, we have the slope formula, and that is the vertical rise over the horizontal run. So for instance, when you're solving, and you'll see here in a minute, there's a formula y2 minus y1 over x2 minus x1. Let's say you got your vertical rise was 15 here, and your horizontal run was 5. Well, that can be simplified as to 3 over 1, which then simplifies to 3. So for this instance, you might have a slope of 3. And this example right here has the slope. So we have our graph, our vertical line, and notice we have a rise of 3 and a run of 1 based on these 2 points. So that's what you're going to be working with, is slope in this section. Here's that formula I was talking about. Slope is recognized as m. The slope m of a line that passes through points x1, y1, this should be a y1 right here, not y2, and x2, y2, this would be m is rise over run. So you have the change in y, taking your y2, subtracting it from your y1 over your x2 minus x1, and that'll help you graph your slope of the line. As shown in the formula above, you must subtract the coordinates in the same order in both the numerator and denominator. So make sure you write all this down, and let's get started with some examples here. So you might be given the point here. It says find the slope of the line that passes through the points 3, 5, and 1, 4. Well, we're going to use the slope of a line. Slope is y2 minus y1 over x2 minus x1. And then once we're done with that, we're going to graph this. So for instance here we have 3, 5, and we have here 1, 4. Now it doesn't matter which one I label as x1, y1, x2, y2, but I do need to be consistent when I set it up using this formula. So here I'm going to label 3 as x1, 5 as y1, 1 is x2, 4 is y2. So now I'll set it up with the formula. So I'll have 4 minus 5, y2 minus y1, over x2, which is 1 minus 3. Now I will simplify that. 4 minus 5 gives me negative 1. And 1 minus 3 is going to give me negative 2. So when I simplify this, I am going to get an answer. Well, negative 1 over negative 2, that's going to give me a positive 1 over positive 2. So my slope is going to be a rise of 1 and a run of 2. So what that means is if I start at, let's say, the point here, I can start at one of the points, 3, 5. 3 over 3 up to 5. And from there, I'm going to run 1 and rise 1 and run 1. So rise 1 and run 2, and this would be my second point. From that point, I can rise 1 and run 2, and that would be my third point. Now these 3 points make my linear line. I can connect it, and there is the slope of my line. Moving on to example 2. Here we have 2 different points. Here they're wanting us to find the slope of 2, 4, and negative 1, 5. So very similarly, we'll set it up. Y2, finding the slope, and let me write it like this, slope, which is your m, which is y2 minus y1 over x2 minus x1. We can label this 2, 4, my ordered pair. I'll have 2 be my x1, and my 4 be my y1. Negative 1, 5. Negative 1 will be my x2, 5 will be my y2. So I can set this up as 5 minus 4 over x2 is negative 1 minus 2. 5 minus 4 is going to give me 1. Negative 1 minus 2, that's going to give me negative 3. So my slope for this line is going to be 1 over negative 3. So pick one of these 2 points, doesn't matter. I'll pick 2, 4. So starting at the origin, I go to the right 2 and I go up 4. I put my first point. Then based on the slope, I am going to rise 1. So I go up 1 point and run negative 3 places. 1, 2, 3. And there's my second point. I can go up again 1 and run negative 3. 1, 2, 3. There's my third point. I can connect those 3 points and notice the line of those for that equation. And this kind of slope right here, we're going to call this a negative slope because it's going down. I think of skiing when you're starting at the top of the hill and skiing down, that would be going down, negative slope. Whereas in the previous slide, this one right here, notice it's starting from the bottom and going up. We can say we're riding up the chairlift. We call this a positive slope. So we've worked with positive and negative slopes with these last 2 examples, using that slope formula to help me find what the slope is and graphing it. Example 3. This will be a different kind of slope than what we worked with the last 2 examples. It says find the slope of the line that passes through 2 points, then graph it. So we have negative 2, 1, 1, negative 3. So my slope, which we call my m, that's y2 minus y1 over x2 minus x1. My points here, negative 2, 1. I can label that x1, y1. My point here, 1, negative 3. I'll label that as x2, y2. Now I'll solve using the formula. So my y2 is negative 3 minus my y1, which is 1, over my x2 is 1 minus, now that's negative 2, so that's a double negative there, minus a negative 2. Negative 3 minus 1 is going to give me negative 4, over 1, we think of this as plus 2, which is going to give me 3. So negative 4, 3 is going to be my slope. So when I look at this, I can pick one of these 2 points, doesn't matter which one. I'm going to choose negative 2, 1. So I start at the origin 0, 0. I go to the left 2 and I go up 1 and I plot my point. Now from there, I am going to, my slope is negative 4, positive 3. So from there, what I'm going to do is I'm going to go to the left 4, 1, 2, 3, 4, and I'm going to go up 3, 1, 2, 3. Now something else I want to show you. Notice like that second point I drew, I ran out of room to go to the left 4 and up 3. From here, I can always go over 2. I can go to the right 4, 1, 2, 3, 4, and down 3, 1, 2, 3. So what I did when I graphed that, I thought of a positive 4 and a negative 3, which gave me a line that fell within this slope right here. And so I just wanted to make note, if you run out of space to graph points on the line, you can think of the negative symbol being in the opposite, either numerator or denominator. So notice now with these 3 points I can connect. Here we have a negative slope. Example 3, they want us to find the slope given the point 0, negative 1 and 0, 4. So I'll use slope, which is my m, change in y, which is y2 minus y1, over change in x, x2 minus x1. And my points here are 0, negative 1 and 0, 4. 0, negative 1, I'll call that x1, y1. 0, 4 is x2, y2. So when I graph this, it will be 4 minus negative 1 over 0 minus 0. Well, 4 minus negative 1 is going to give me 5 over 0. Can you divide by 0? You cannot. So this is actually what we call an undefined slope. And you'll notice if I graph these 2 points, it's going to give me a vertical line, a vertical slope. So if I have 0, negative 1, there's that point. 0, 4, 0, 1, 2, 3, 4. Notice I have a straight vertical line. I'll connect those 2 points. And it's undefined. Vertical lines are always undefined because you'll always be dividing by 0, and you cannot do that. If you divide by 0 on your calculator, you'll get an error. I just want to point this out, just a note, that if you, for instance, if that was switched, if it was 0 minus 0 over 4 minus negative 1, let's just say, that would be 0 over 5. When you have 0 for your numerator and a value for your denominator, we call that a zero slope, and that would be a horizontal slope. So you might run into that when you're working on the bookwork, and we can review that in class tomorrow, but I just want to point that out in these notes as well. So go ahead and practice some of this, and like I said, we'll review it in class.